In this video, we will learn how to find derivative of exponential function. For finding derivative of exponential functions, we need these two formulas. Derivative of e to the u is e to the u u prime, and derivative of b to the u is b to the u u prime ln of b. The best way that you can learn these formulas is to do lots of examples with them. Let us start. As the first example, suppose we want to find derivative of the function y equals e to the 5x. For finding derivative of this exponential function, we have to use this first formula. Derivative of e to the power of u is e to the u u prime. But what is u in this formula? U can be any function, any expression in terms of the variable, usually x. So in this first example, u is actually 5x. And based on this formula, derivative of e to the u is e to the u, so the function itself, the same function, multiplied by u prime. But what is the role of this u prime in this formula? U prime here is because of chain rule. If you remember from chain rule, when we take derivative of a function, we have to take derivative of the outside function, which in this case is e to the u, and then multiply by derivative of inside function. Here the inside function is u, and so we have to multiply it by u prime. So in general, derivative of e to the u is e to the u, the same function, then multiply it by u prime, or derivative of the power. So derivative of e to the 5x is e to the 5x, e to the u is e to the u, then multiply it by u prime. U is 5x and derivative of 5x is 5. So we have to multiply this by 5. And if you like, you can rewrite your answer in the form of 5 e to the power of 5x. Another example. Suppose we want to find derivative of e to the negative 2x. If you like, pause the video here and try this example by yourself. Based on the formula that here we have, derivative of e to the u is e to the u. So derivative of e to the negative 2x is e to the negative 2x. Don't forget, multiplied by u prime. What is u? U is negative 2x in this example. U is the power. And derivative of negative 2x is negative 2. So derivative of the function e to the negative 2x is negative 2 e to the power of negative 2x. Another example, e to the power of sine of x. Based on our formula, derivative of e to the sine of x is e to the sine of x. Rewrite the same function, multiplied by derivative of u. What is u in this example? U is sine of x. And derivative of sine of x, if you remember, derivative of sine of x is cosine of x. Y equals 5 to the power of x. For finding derivative of 5 to the x, we have to use the second formula. The b value is 5 and the u is x. Derivative of b to the u in general is b to the u, u prime, ln of b. Don't forget, ln of b, base, not the power. U is a function. U can be any expression in terms of x. U can be x, x to square root of x, sine of x, cosine of x, any expression in terms of x. And derivative of b to the u is b to the u. So derivative of 5 to the x is 5 to the power of x. Multiplied by u prime. U prime means derivative of u. And because u is x in this simple example, derivative of x is 1. And finally, we have to multiply by ln of b, ln of 5. And again, I should mention why u prime is here in this formula, because of chain rule. U prime is derivative of the inside function. And if you like, you can simplify your answer and write it as 5 to the x ln of 5. So derivative of 5 to the power of x is 5 to the x ln 5. Maybe you wonder why in the derivative of e to the u here we have only e to the u prime, but when it is b to the u, more general, any number to the u, derivative is b to the u prime ln of b. Why we don't have ln of b here also? Ln of e actually. The base is e, so based on the second formula we have to have ln of e in the first formula. But why we don't have? Remember that we know ln of e equals 1. And because ln of e is 1, we don't need to put ln of e in this first formula. So actually we have ln of e in this formula, but because ln of e is 1, we do not put ln of e in the end of this formula. Another example. Suppose we want to find the derivative of the function 10 to the power of cosine of x. Y prime equals 10 to the power of cosine of x, derivative of cosine of x, derivative of u, and derivative of cosine of x is negative sine of x, and in the end multiplied by ln of b, ln of 10. Now look at this example. Suppose f of x is given by this formula, x to the power of 3 plus 3 to the power of x. For finding the derivative of f of x, note that the two terms that here we have in this function are completely different expression. The first part, x to the 3, is a simple polynomial. It's a polynomial with degree 3. The power is constant, the base is variable. But the second part, 3 to the x, is an exponential function. So pay attention to this difference. And so the formula for finding the derivative of each of these terms is completely different. For the first part of this function, we have to use power rule, because x is raised to a number. And based on the power rule, the derivative of x to the power of 3 is 3x squared. We bring the power down to the front of the term and we subtract the power by 1. But for finding the derivative of 3 to the x, because it's an exponential function, we have to use this formula. The derivative of 3 to the x based on this formula is 3 to the power of x multiplied by u prime. U is x and derivative of x is 1, so times by 1. And in the end, ln of base, which is 3. So derivative of the function x to the 3 plus 3 to the x is 3x squared plus 3 to the x ln of 3. Now look at this example. F of x is given by this formula, e to the square root of x plus e to the power of 10 plus x to the power of e. Now look at this example. F of x is given by this formula, e to the square root of x plus x to the power of e plus e to the 10. F prime of x equals to, for finding the derivative of e to the power of square root of x, we need this first formula. The derivative of e to the u is e to the u. The same function, don't forget to multiply it by u prime. U prime is derivative of square root of x. If you remember, for finding the derivative of square root of x, you can rewrite it as x to the power of 1 over 2, and then derivative of x to the 1 over 2 is 1 over 2, x to the power of 1 over 2 minus 1, which is finally 1 over 2, x to the negative 1 over 2. But I highly recommend you to memorize this shortcut. Derivative of square root of x is 1 over 2 square root of x. I know these two answers are the same, but because we see the derivative of square root of x again and again in calculus, so it's a good idea to memorize the derivative of square root of x. And the derivative of square root of x is 1 over 2 square root of x. So let's back to our question. Derivative of e to the square root of x is e to the square root of x times derivative of square root of x, which is 1 over 2 square root of x, plus, for finding derivative of x to the power of e, we don't need to know derivative of exponential functions because x to the power of e is not actually exponential function. X is raised to a power which is a number. We have x to a number, x to a power. And for finding the derivative of such expression, we need simple power rule. And based on the power rule, derivative of x to the power of e is bring the power, the constant power, to the front of the term and then subtract 1 from the power. The x to the e is similar to something like x to the 5, x to the 10. How you do derivative of x to the 5? 5x to the 4. It's completely similar. Bring e to the front and subtract the power by 1. And in the end, we want to find the derivative of e to the power of 10. Note that in e to the power of 10, everything is constant. E is a constant number. You know that e is approximately 2.7 is a number raised to a number. So e to the 10 is a number and there is no variable in this part of this function. And the derivative of any constant is 0. So f prime of x finally is e to the square root of x over 2 square root of x plus e x to the e minus 1. H of x is given by this formula, e to the power of 2x. We want to find h prime of x, h double prime, h triple prime of x, and finally fourth derivative of h of x. We have to go step by step. First, we have to find h prime of x, the first derivative of h of x. Based on the formula for e to the u, derivative of e to the u is e to the u, the same function, multiplied by derivative of inside function or u, which is 2 in this case. Derivative of 2x is 2. If you like, you can rewrite this answer in the form of 2 e to the power of 2x, or leave it in the original form. Now let's see what is h double prime of x. For finding h double prime of x, we have to find the derivative of h prime of x again. So we have to find the derivative of 2 e to the power of 2x. For finding the derivative of 2 times e to the 2x, 2 is a constant, is coefficient for e to the 2x. So we write the constant 2. Based on the constant multiple rule, we have to write the constant. Don't worry about the constant, just write the constant. And take the derivative of the function, derivative of e to the 2x. Derivative of e to the 2x again is e to the power of 2x times 2. Derivative of e to the u is e to the u prime. Derivative of e to the 2x is e to the 2x times 2. If you multiply these two by these two, it would be 4e to the 2x. Now we want to see what is h triple prime of x. Again, we have to write the coefficient 4 and then take the derivative of e to the power of 2x. And the derivative of e to the 2x is e to the 2x times 2. 4 times 2 is 8 e to the power of 2x. Probably now, by looking at h prime, h double prime, h triple prime, you can see a pattern in these derivatives, and probably you can guess what the fourth derivative of h of x will look like. For finding the fourth derivative, we write 8 again is coefficient, and we take derivative of e to the power of 2x. Derivative of e to the 2x is e to the 2x times by 2. 2 times 8 is 16. So the answer is 16 e to the 2x, which was completely predictable. Look at this example. F of x is given by this formula, x squared e to the power of x. By looking at this function, we can see that this function is actually multiplication of two expressions, x squared and e to the power of x. X squared times by e to the x. And so for finding the derivative of this function, we need to know the product rule. Let me remind you the product rule for derivatives of the functions. Derivative of f times g, derivative of f, which is a function, and g, another function, equals f prime, which means take the derivative of the first function, multiplied by g, the second function, plus write the first function f, and then multiply it by derivative of second function g prime. So based on this formula, f prime of x is, first we have to take derivative of x squared. Derivative of x squared is 2x multiplied by the second function, plus write the first function x2 and multiply it by derivative of second function. Derivative of x e to the x is e to the x, because derivative of e to the u is e to the u, multiplied by u prime, but u prime in this case is 1 because the derivative of x is 1. If you like, you can put 1 here also. And finally, you can write your answer as 2x e to the power of x plus x squared e to the x. J of v is given by this formula. V to the power of 3 times 3 to the power of v. Again, for finding the derivative of this function, we have to use product rule. V to the 3 is our first function, and 3 to the v is our second function. J prime of v is, based on the product rule, first we have to find the derivative of the first function, v to the 3. And the derivative of v to the 3 is 3v squared. Based on the power rule, derivative of v to the 3 is 3v squared, multiplied by 3 to the v, multiplied by second function, plus write the first function, v to the 3, multiplied by derivative of second function. For finding derivative of 3 to the v, we have to use this formula. Derivative of b to the u is b to the u prime ln of b, and so derivative of 3 to the v is 3 to the v, the same function, multiplied by u prime. U here is v. U prime means derivative of v. What is derivative of v? Note that in this example, v is completely similar to x. What was the derivative of x? 1. And so the derivative of v is also 1. V plays the role of the variable of this function. Usually our variable is x or t, but here our variable is v. And the derivative of v is 1. And finally, ln of b, ln of 3. If you want, you can rewrite your answer as 3v squared times 3 to the v plus v to the power of 3, 3 to the v ln 3. Let's try another example. F of x is given by e to the x minus e to the negative x over e to the x plus e to the power of negative x. To find derivative of this function, we need these two formulas, derivative of e to the u and quotient rule. Let me remind you the quotient rule. When we have f over g, which in this example f is the top and g is the bottom function, derivative of f over g is f prime, which means take derivative of the top function, multiply it by g, which is the bottom function, minus, right, the top function, multiply it by g prime, which means derivative of the bottom function, all over g squared, the bottom function squared. Before we start and find the derivative of this function, let me show you what is the derivative of e to the x, which we need here for this example, and e to the negative x. Derivative of e to the x based on the formula that here we have is e to the x times u prime, u is x and derivative of x is 1. So derivative of e to the x is e to the x. And derivative of e to the negative x is e to the negative x times u prime, u is negative x, and derivative of negative x is negative 1. So derivative of e to the negative x is negative e to the negative x. Now let's see what is f prime of x. First we have to find derivative of the top function. Derivative of e to the x, as we see here, is e to the x minus derivative of e to the negative x is negative e to the negative x. If we multiply it by another negative, it becomes plus e to the negative x. So let's review again. Derivative of e to the x is e to the x, and derivative of e to the negative x is negative e to the negative x. But because we have a negative in front of this term, if you multiply that negative by this negative, it becomes positive. Multiply by bottom function. Based on the quotient rule, we have to take the derivative of the top function, multiply by the bottom function. Then minus, write the top function, which is e to the x minus e to the negative x. Multiply it by derivative of the bottom function. In the bottom we have e to the x, and derivative of e to the x is itself e to the x, and derivative of e to the negative x is negative e to the negative x. All of this over e to the x plus e to the negative x squared. So this is the derivative of f of x. If you want, you can simplify this answer. The part of this answer that you can simplify is the numerator of this fraction. But how you can do that? There are many different ways for simplifying numerator of this fraction. One way for simplifying this fraction is to multiply the brackets by each other, and then you will see that many terms cancel each other. The other way is to notice that the brackets are actually the same, and so you can rewrite, for example, this part as e to the x plus e to the negative x squared minus, and because these two brackets also are the same, you can rewrite them as e to the x minus e to the negative x squared. Then for simplifying this expression, you can use the square identity for each of the brackets. What is the square identity? A plus b squared is a squared 2ab b squared, this identity. And if it is minus, we have a minus here. The other way for simplifying this expression is using the square difference identity. A squared minus b squared. A is the first bracket squared minus the second bracket squared, which is a minus b times a plus b. But all of these methods need some identities. The easier way maybe for you is to multiply simply the brackets by each other, and then you will see some terms cancel each other. Let's see what happens if we multiply the brackets. E to the x times e to the x is e to the 2x. e to the x times e to the negative x, e to the power of x times by e to the negative x equals e to the 0, because the base are the same. If we add the powers, x minus x is 0 and e to the 0 is 1. The other way that you can see why e to the x times e to the negative x is 1 is to notice that e to the negative x is actually 1 over e to the x. We bring e to the x to the denominator and we make the power negative positive. And now e to the x and e to the x cancel each other and it remains 1. So e to the x times e to the negative x is positive 1. E to the negative x times by e to the x is again 1 with the same reason, plus e to the negative x times e to the negative x is e to the negative 2x minus, don't forget this minus that here we have. You have to apply this minus in every term that you get from multiplying these two brackets. E to the x times e to the x is e to the 2x, but because we have a negative here, it becomes negative e to the 2x. E to the x times by this term becomes e to the x times e to the negative x equals 1. But don't forget here we have a negative. And a negative for each term, negative times negative becomes positive, plus 1. If you multiply this term by this term, e to the negative x times e to the x is 1. But we have a negative in here. And a negative for every term, again positive 1. And finally, negative e to the negative x, this term, multiply by this term is minus e to the negative 2x. Why negative? Because this first term has a negative. Second term has also a negative. Negative times negative positive. But for every term we have another negative. So 3 negative here we have. If you multiply 3 negative by each other, it's negative. So negative e to the negative 2x. All over e to the x plus e to the negative x squared. Now let's see what terms cancel each other in numerator. This e to the 2x cancels with this negative e to the 2x. And this e to the negative 2x and this minus e to the negative 2x cancel each other. So what remains in top? 1 and 1 and 1 and 1. So the answer is 4 over e to the x plus e to the negative x all squared. Before I finish this video, let me show you some interesting examples about derivative of exponential functions. Suppose f of x is e to the power of 3x. What is f prime of x, f double prime of x, f triple prime of x, and in general, what is nth derivative of f of x? Let's see what is f prime of x. We know that derivative of e to something is the same function and multiply it by derivative of the power, derivative of u, which in this case is 3. Derivative of 3x is 3. So f prime of x is 3 e to the power of 3x. Now let's see what is f double prime of x. 3 is a coefficient. Based on constant multiple rule, we have to write the constant and we have to take derivative of e to the 3x. Derivative of e to the 3x is again e to the 3x times 3. If you multiply 3 by 3, it's 9, so it becomes 9 e to the 3x. Now probably you can guess what f triple prime of x can be. The first derivative was 3e to the 3x. The second derivative 9e to the 3x. So the third derivative probably is 27e to the 3x. Let's see, is it correct? We write the constant 9. We take derivative of e to the 3x again. Derivative of e to the 3x is e to the 3x times 3. 3 times 9 is 27, so the answer is 27 e to the 3x, as we expected. Now, based on this pattern that we can see here, probably we can guess what nth derivative of f of x can be. So if we continue taking derivative again and again, the nth derivative of f of x in general is, again, note that the first derivative is 3e to the 3x, or actually 3 to the 1e to the 3x. The second derivative is 3 to the 2e to the 3x. 9 is 3 to the 2. The third derivative is 3 to the 3e to the 3x, because 27 is 3 to the 3. So, nth derivative is 3 to the power of n e to the 3x. The given function is x e to the power of x, and we are asked to find y prime, y double prime, y triple prime, and nth derivative. For finding y prime, we have to use product rule because x and e to the x are multiplied by each other. Based on the product rule, first we have to take derivative of the first function, which is x. Derivative of x is 1, so we have 1 times the second function plus write the first function x and multiply by derivative of second function. Derivative of e to the x is e to the x. So our first derivative is e to the x plus x e to the x. Now let's see what is y double prime. Derivative of e to the x is e to the x plus, again here we have x e to the x, which is exactly similar to our original function. And we see that derivative of x e to the x is this expression. So derivative of x e to the x is exactly the same thing. You don't need to do the process of taking derivative of this expression again. The answer is ready here. But anyway, if you do it again, you get the same result. Derivative of x is 1 multiplied by second function e to the x plus write the first function x multiplied by derivative of second function, which is e to the x. By looking at y prime and y double prime, probably you can see a pattern. In y prime we get 1 e to the x plus x e to the x. In y double prime we get 2 e to the x plus x e to the x, because we can rewrite this as 2 e to the x plus x e to the x. And so we can guess that the third derivative should be, and so we expect our third derivative will be something like 3e to the x plus x e to the x. But let's see what is the third derivative. We have to write the 2 because it's coefficient for e to the x, and we have to take derivative of e to the x plus, for finding derivative of x times e to the x, again we have to use product rule, or we can use this answer, because this answer is the derivative of x to the x times e to the x. So derivative of this term is e to the x plus x e to the x. 2e to the x plus e to the x is 3e to the x plus x times e to the x. By looking at y prime, y double prime, y triple prime, we can guess that nth derivative of y is n e to the x plus x e to the power of x. Because in y prime we had 1 e to the x. In second derivative we had 2 e to the x. In third derivative we had 3 e to the x. So in nth derivative we expect to have n e to the x plus x e to the x, which is fixed, and in every derivative we have that term. Let me show you one more example, and then I promise you that I will finish this video. Suppose y is given by this formula. Y is 7 to the power of x, and we want to find a general formula for nth derivative of this function. as our previous examples, first we have to find first, second, third derivative, and hopefully we can see a pattern and guess what nth derivative of this function can be. Let's see first what is y prime. For finding y prime, we have to use this formula. Derivative of b to the u is b to the u prime ln of b. And so derivative of 7 to the x is 7 to the x. b is 7 and u is x. Derivative of x, u prime means derivative of u, and u is x, and derivative of x is 1, multiplied by ln of b, which is ln of 7. So our answer is 7 to the x ln 7. Let's see what is y double prime. When we want to find y double prime, we have to take derivative of y prime again. By looking at y prime, maybe you think by yourself, we have to use product rule. But note that in this expression, 7 to the x is the only part that we have variable in it. 7 to the x has variable x. But ln of 7 is just a constant. For finding derivative of 7 to the x times ln of 7, ln of 7 plays the role of coefficient for 7 to the x, because ln of 7 again is a number and you don't need to use product rule. So we write ln of 7, and then we have to take derivative of 7 to the x. Derivative of 7 to the x again is 7 to the x ln 7. Now by looking at y double prime, we see that ln 7 and ln 7 multiply by each other. So we can rewrite it as 7 to the x times ln 7 squared. Now let's see what is the third derivative. Again, ln of 7 all to the 2 is a number, a constant. Write that constant and multiply it by derivative of 7 to the x. And derivative of 7 to the x is again 7 to the x ln 7. If you multiply now ln of 7, which is actually to the power of 1, by ln of 7 to the 2, we get 7 to the x ln 7 all to the 3. Can you see the pattern? Nth derivative is 7 to the x times ln 7 all to the n.